Welcome to the fourth tutorial in tutorials about Excel spreadsheet. I'm Professor Michael D. Robertis, Department of Physics and Astronomy at York University. In this tutorial, we'll learn how to import text files. It could be delimited files, space, commas, or a variety of other formats that Excel will accept. What we're going to use today is a file I generated using the proprietary program Mica from the Astronomical Almanac folks. I've asked, in this case, the data for each day of the year 2019. As you'll see, I've asked for, at noon, the right ascension, hours, minutes, seconds of the sun, its declination in degrees, arc minutes, arc seconds, and the distance from Earth center to Sun center in astronomical units. So I'd like to import that into Excel. So I have a blank worksheet. I go to File, and I ask to open, and I happen to know it's called sundata.txt. And Excel will then begin an import wizard. A variety of options. You should again look at them very carefully. These aren't fixed width, they are delimited in spaces, but they could be commas or tabs. That's frequent. Click on Next, and then you can click on your delimiters. Mine happens to be space, I believe, and Excel says if that's so, these are what the columns I expect. That's just right. If I proceed to Next, I can also start formatting or telling Excel the different formats of the various columns. I'm good with just saying Finish now, but you can again explore a little bit more. So this is what Excel produces. Again, this is for 2019, the year, the month, January through December, day 1 through whatever in the month. The right ascension, hours, minutes, seconds, the declination, degrees, minutes, seconds, but the SIG and the sign of the declination here is written separately. That's because, particularly for novices, introductory students like maybe some of yourselves, the decimal degrees is fine. Negative 23.81725, for example, is very clear. But how does it play out when you have degrees, minutes, seconds? Well, it's the entire angle, negative sign, right? So we'll show how to write that a little later and calculate that. And then finally, the Earth-Sun distance. Now, I seem to recall that there were more significant figures in the original file I just showed, so I'm going to open the column up a little bit, and there we are. In fact, there's the full range of significance in the figures. Now, I want to tidy this up just a little. I want to put, for example, an empty column between the various important data components here, for example, between the date and the right ascension. I'm going to carry on with that and make it a little bit more attractive for the headers, and then I'll see you in a moment. So you see that I've added the dates and right ascension and declination and Earth-Sun distance a little more attractively with these spaces. Now, there are a few things I'd like to calculate right off the top from these data. For example, I'd like to take the average of the Earth-Sun distance. That should be, if Kepler were correct, exactly 1.000. So let's have a look at how this works. I'm going to proceed to the very bottom of the column just to make it a little bit more attractive, a little easier to deal with. So I'm at the bottom, control down arrow, control top arrow would get you to the top of the column, at least with the data part of the column, and then control down arrow. So let's take a look at the average, and we'll calculate it here. I happen to know that, average, N4 to N368, I believe, and return. And notice that it's 1 to a number of significant figures, but it's a little in excess of 1. So is there a mistake here? Has Mica made a mistake? Has Professor D. Robertis made a mistake? No, in fact, there are some issues here that I don't want to get deeply into about taking averages and what does it really mean for a semi-major axis. But for the moment, let's just leave it at that. How about the minimum distance, the minimum separation? And now we'll calculate the minimum. What is the minimum and maximum for the separations in this column? So minimum So the minimum value is 0.9833, etc. Astronomical units, that would be perihelion, and that is very early actually in the year, around between January 3rd, in this case for this particular year, through January 5th, depending on the year. So that's always very interesting, of course, that it occurs in early January, the coldest part of the year, certainly in Toronto, and yet when Earth is closest to the Sun. Okay, well, maximum. And in fact, it's 1.017 or so astronomical units. So you see that, in fact, Earth's orbit is pretty circular to within a couple of percent at least. So that turns out to be very interesting. Now let's go back to the top here. Now I'd like to show some of the power of just what one can do with a spreadsheet. So for example, we have the right ascension here in columns E, F, and G. And that is in hours, minutes, seconds format. Now, if I want to write in, let's say, column P, I want to write the equivalent decimal format for right ascension. And I think we all know how to do that. So it's the operation. You add the hours, then you add 1/60th of the minutes. But I'm going to write it in the good old computer science way. And I'm going to... And as you can see here, I've divided the minutes by 60, the seconds by 60, added to the minutes, then divided that by 60, and then added that to the hours, and that should be sufficient. And indeed, this is the correct answer. Now I want to Control C, and then click on this, and in fact import that equation all the way to the last cell. Then Control V, which is the simple paste, and so this is in fact the RA in decimal notation, and again you can make this a little bit more attractive. Now what about here in declination? Well, it's a little more complicated. It is quite easy to do it in one step, but I'm going to for visualization purposes I'm going to do it in two steps. First of all, I'm going to calculate the declination just as I did for the right ascension, ignoring the SI, GN, the sign. Okay, so again, it's equal to J4 plus K4 plus L4 divided by 60, return. And this is the decimal declination, modulo the sign, SIGN. Go to the corner here, double click, because I have elements already in the adjacent column, so this will go all the way down. But notice that these are all positive, and that's what I've intended. Now I want to introduce a logical function, if. What I'm going to say here is, if the character in I4 is the negative sign, multiply Q value by -1. If it's not, it has to be a positive sign, just leave it as it is. So how do we write that? We use the if sign. So if, in fact, I4, and because it's a character string, equals double quotes, because it's character or text, negative, double quotes, then, if it's true, I want to write in that cell the element -1 times Q4. And if it's false, just write Q4 again. And so you see that it's changed to the negative sign appropriately. Double click, imports that equation all the way, or that logical all the way down. And let's have a look. The positives have become negatives, but the negative sign is appropriate. Let's go down to the positive sign, and we see the positive remains positive. Okay, so that's very helpful. Let's take a look at maybe a couple of other functions that might be very helpful. For example, there's a concatenate function, a number of text functions. I could, let's say, concatenate the year, month, and day all in one character string. How might I do that? You concatenate, and then as many strings as you want. For example, A4, B4, and C4, return, and it concatenates it to a single text. I could do the same thing for a variety of things. For example, I could now take this particular character string, and I could type left, and it's what's the left certain number of characters, sort of strip it from that character string, say T4, which I've just calculated. How many characters from the left? 3. Return, and now we have 201. I could use the right function too to do the same thing, but the rightmost characters, I could use the mid function. Very, very powerful. The logical and is also function is very important here, but you can check all that out by looking at the formulas function. So there's no need to plot here. You've already seen some pretty sophisticated plots for introductory level. But these are the kinds of things you can deal with in your spreadsheet. Very powerful and help you to solve your equations.